Well, howdy, physics sleuths and inquisitive souls. Welcome again to Dynamic Gravity. So, on this episode, excuse me, brain damage from the war. I would like to go over what a gravity field looks like what it really looks like. And as it turns out, there's two of them. And yeah, first of all, if you are new to this channel and you have not yet done this, I strongly encourage you to read my paper and the description of this video, all my videos in this channel, about dynamic gravity, how it works on a subatomic level, and the math that's involved in there that I use to calculate everything throughout the universe. And yeah, currently I'm in the process of trying to obtain all the near galaxy data, like from the Harvard data set, but it's really hard because I'm not in academia and they don't want me to be, and they don't want me to contribute. They don't want to hear my opinions. They don't care if I'm right or wrong. They just want to serve themselves. Welcome to the world of science, as it always has been. But maybe I can, fully test out my math if I can get all that data and see how well it holds up according to observations. But we'll see. One of many, many projects I'm working on right now related to dynamic gravity. Now, what does a gravitational field look like? Well, it depends. The last episode I did, we delved into what a gravimetric field is, how that's created, what you can do with that. And essentially, a gravimetric field is a gravity field with coral. And that's essentially going to make it look like a magnetic field, because a magnetic field is an electric field with curl. So, and all curl means essentially, you can use different definitions depending on what you're trying to look at. But essentially, it means instead of all these rays of virtual photons shooting off into space randomly, it means they're all going to have a start point and an end point. It's all gonna be a complete loop. So this is what a magnetic field looks like, and they can do some pretty crazy things. And a gravimetric field also looks like this. And it appears that gravimetric fields are what spaceship technology kind of runs on. Not a gravity field, but a gravimetric field. FYI. So, this is one form of a gravitational field, will be a gravimetric field. A second form, and keep in mind, a gravimetric field would not really be formed very easily. You would have to have a lot of positive charges in the form of protons or quarks spinning around very fast, moving, accelerating. And that's not an easy thing to do unless we're talking about super celestials like black holes or neutron stars, that sort of a thing. So don't expect that they're going to measure the gravimetric field of the Earth anytime soon. Is there one? Oh, sure, there probably is, but it's probably very, very small and completely overpowered by the standard gravitational field that it emits. One day maybe we'll be able to distinguish the two properly, though. So, a true gravitational field, like we're useful to us, not in terms of traveling the cosmos or super celestials, but on a planetary and celestial scale, would be a regular gravitational field. And that, you would think, would look pretty much like an electric field. In fact, it would look like an electric field. The question is, what does an electric field really look like? There are many diagrams like this, where they will have all the lines that will intersect, like with a starting place and then an ending place, right? The problem is, though, this is an electric field with coral. this is an electric field where the lines are being bent to bring them back around to the charges at a definite start and a finish point. This is a magnetic field. But this author or this artist thinks that this is how an electric field would work. But it's not. Even on Wikipedia, it's the same thing. You can see they have the bending of the virtual photon streams. Yeah, they're all gonna, start at one place and end at another. And that's adorable. But yeah, this is once again, this is a magnetic field with the magnet being, linking the two. This is not what an electric field looks like. I'm telling you, it doesn't. This is not how it works. This is impossible. Mainly because, and let me tell you why it's impossible, why I'm so positive this is not what it looks like. Because you cannot have some force acting on another thing at a distance, okay? Either the force has to be a force-carrying particle that moves to the thing that then delivers the force in whatever direction it's going to be from whatever mechanism you're using, or nothing's going to happen, okay? We cannot spontaneously exert force upon the planet of Pluto here at the Earth when it's so far away. We can't just snap our fingers and be like, now we're going to make Pluto stop spinning. It's going to keep spinning, dude. You have to either shoot something there to it that's going to interact with it to make it stop spinning, or you have to have a bridge of sorts, bridging the two that's going to exert force. I mean, you can't have force at a distance magically happening. This does not exist. But this is exactly what this diagram is saying is happening to an electric field. Now, in a magnetic field, we know that this is the case, this is what it looks like. But an electric field, no. This is what an electric field really looks like, okay? It's, as you can see, the force is going randomly, keyword there, randomly, off in all directions at all times. And each one of these arrows would be a streamer, you could argue, or say it is, from a virtual photon. And I'll tell you, I'm calling them that here in a second. And these ones just happen to be on a path randomly right to this other charge. And so they are going to directly affect it. Any ones coming from this too. Although I know Maxwell equation says it starts here and ends here. I have other mechanisms involved, but let's pretend it is. These are the ones that are actually going to affect this charge. These ones are not. These ones are going off into the opposite direction, and they're not going to be bent by this because there's no magical entity bridging this charge with this streamer of force of virtual photon emitted from this charge. There's nothing linking these two together. The virtual photon is the bridge linking it together, and only these ones are going towards it. So that is what an electric field really is going to look like. It's going to be highly inefficient, shooting everything off in all directions, and only a small percentage of what it emits is actually going to exert force on a nearby particle. But this is the way it works, I promise you. And so, what does this look like on a large planetary thing? I think this is probably, not bad. I mean, these are obviously being affected by a magnetic field. I think this is the corona of the sun, which is a lot of plasma being ejected out and whatnot, and the magnetic field, bends it around, so they're going to bend. But let's pretend there's no bend in this at all, and it's just straight being emitted from all directions, okay? That is essentially what a gravitational field is going to look like. And any object that, say, comes around here, all these lines of force, these streamers of the virtual photons being emitted out of the celestial body just from random mass and random directions, it's going to hit anything in its way and exert a force. And in my last video, was it my last video? I don't know. One of the videos, I go off into virtual photons, and we come to the realization that virtual photons are essentially photons that are less than 1 hertz. And less than 1 hertz, like 1 hertz is the lowest we can measure, whatever. Any real photon, I'd have to look up like whether it's a super low frequency photon or whatever they're called. But they go down very low to 1 hertz, and that's it. That's the end of the photon scale. 1 hertz, meaning 1 cycle per second seems to be the magic cutoff line where we just don't call them photons anymore. And anything below a hertz, like half a hertz or a millionth of a hertz, is now going to be a virtual photon of sorts, which all matter is going to be emitting constantly as long as it's not at absolute zero, which all matter throughout the universe is not absolute zero. So it's going to constantly be emitting these virtual photons, so you're going to constantly have gravity being emitted from everything. So yes, I am saying that if you could make matter absolute zero, it would cease to create a gravitational field of any sort. It would still be affected by a gravitational field, but it would cease emitting its own gravitational field, if that makes any sense at all. Maybe, I don't think that can be done as an experiment. Just trying to think of different ways, experiments I could do to prove all this. That's a hard one to prove, though. Maybe that's why no one's done it yet. So, yes. So we have any photon that lasts longer than a second is going to have less than 1 hertz, and it's going to be a virtual photon. And it takes a second for a photon to travel from the Earth to the Moon. So essentially, any photon that's longer than a distance from the Earth to the Moon is going to be a virtual photon and hence could potentially transmit gravity, right? Okay. Let's, now, I made this diagram. Oh, wow. Oh, that is unfortunate. Well, I am terribly sorry, guys, but it looks like it's not going to read the PNG. Let me try one thing. Okay, so unfortunately, I was unable to make my artwork come up, but I've been able to upload it to a website and show it to you that way, so we'll do that. I tried to make it an AI as best as I could, but it was really hard. It didn't want to work with me. Imagine, if you will, the Earth, right? And every atom on the entire planet is, I mean, yeah, sometimes it's emitting higher frequency photons and being used for that purpose, but when it's not, it's having heat move it in the form of motion. That's what heat is motion atoms. And as it's doing this, it is releasing virtual photons constantly. And these virtual photons from every atom are going to be random. It's going to be shoot all directions, going across each other, through each other, everything. So this right here only shows it, being, omnidirectional, kind of from the Earth, going outward, radial towards. But that's not really the case. It's going to be everywhere. All right? And as the Earth is spinning, keep in mind, these are longer than a second, maybe multitudes of seconds. We don't know. I don't know. So nobody knows yet. And so that's the question. Is as the Earth is spinning, do these lines of streamers of virtual photons going in all directions, do they spin as well, like in a curve? Like as the Earth spins, and they start off straight, but as the Earth spins, they curve, right? Is that what's going on? Because that's the way you would expect it to go on, right? As they go out and the Earth spins, they're now going to kind of have a natural sort of curve to them. Or is it that they have some sort of rigidity to the photon, where the photon is somehow binded together? It is not just like a stream of water that is not really connected, but it is an entity, the very smallest measure of energy, a photon that we can have, a quantum measurement, and that seems to be the case. And so what's going to happen as the Earth spins, it is going to spin rigidly. Maybe not perfectly rigidly. It's going to probably have some bend too, but not the same bend as if it had no rigidity at all. It's going to be probably somewhere in the middle is what I would expect it to be. Okay? And you're like, why do you keep talking about this? This is so weird. Right. Well, the reason why I keep talking about this is because, let's say, we have a planet, right? And it is spinning. And it is going in directions. And we have these streamers of virtual photons. And we also have another planet, right? Like a smaller planet, like the sun and Earth, okay? Now, as this thing spins around, boop, 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 boop. You see what happened? You see how that line intersects the Earth, right? And it's going in a direction to this way. It's spinning around. It's using force. The Earth's force is being spent in making this virtual photon go around like this. Well, this virtual photon is hitting the Earth and creating the force known as gravity. And as it's doing this, it's not doing it in just one simple direction. So the Earth is not just simply being dragged, towards the sun. What's happening is the Earth is being dragged towards the sun, and it's going off to the side, right? And if this the sun is spinning fast enough, it is definitely going to make the Earth or whatever spin around it. And the Earth is going to eventually, after billions of years of this minute force being put upon it, pushing it this direction, it's going to go this direction, the same direction that it is spinning, that the sun is spinning. And that is why we have every single observation that we have ever made in this universe of a spinning object. Everything that orbits it is always orbiting it in the exact same direction that it's spinning. This is the way it is. Now, if you believe in general relativity, you have no choice but to say this is just a coincidence. There is no mechanism they know of. They can do this. I mean, maybe, I guess they could say frame dragging, I guess, if they really want. Now that I think about it, they could say that the very space-time itself is being pulled by the planet, but they can't even measure space-time in a laboratory. It doesn't exist, all right? It's a made-up concept to make general relativity click, and to try and explain why the math of general relativity works out. It doesn't. It's not right. This is what's right. This is how gravity works, okay? And this is what it looks like. It's just a million rays just coming from the sun in all different crazy directions. And each one, as it hurts, of longer than a second. And as this sun spins, all of these are going to spin with it. And every planet that is in the range of this is going to spin as well. It's just naturally going to happen. Like, you can't get around it. Let's see if I can just a little more. And then, yeah, you see, as these streamers of virtual photons carrying gravity are hitting this Earth and dragging it along with the same direction of the sun. This is how a gravitational field looks like and how it behaves, how it exerts force, not only pulling things towards it, but also in the direction that it's spinning as well. I don't have all the answers. I believe it or not, I really don't know everything, but I do know a lot. I know a lot more than most anybody else on this planet knows, and that's the truth of it. So, I think with the limited tools I have available right now, that's probably about the best I can do for you to try and show you what a real gravitational field looks like. Just ultimately, like I said, think of something like this where it's so many millions and billions of streamers together that it just becomes a ray, almost like a ray of light. And then you have so many millions and billions of rays of light that they just all merge into just this thing that almost, looks like space itself, surrounding omnidirectionally, from a celestial body. And as it spins, it's going to drag everything else around it because the fact that virtual photons have such a long lifespan compared to, say, an X-ray or a gamma ray, which is, very, very minute, very small photon. And releasing all that energy it's carrying like instantly as compared to a virtual photon where it's like over multitudes of seconds. Yeah, I'm sorry, this video went so long too. I'm sorry, guys. Anyways, I hope you learned something. I'm planning my next video, probably my most ridiculous and intense and serious one ever yet. It's gonna blow your mind, so don't miss it. You guys have a good day, and catch you on the flip side. All right, goodbye.
Like, subscribe, submit.